Hey everybody, welcome to another Probably Private. I'm Catherine Jarmal, and today we're going to talk about search and retrieval. So obviously, as you're getting started with your local AI, you've seen a few ways to get your documents all into some sort of text form, whether they're complicated PDFs or whether they're images, even videos. You can do some of the image workflows. And now that you have everything in text, you might want to figure out how to search and retrieve things from multiple different types of mediums or multiple different locations, and then use them for your AI system. So let's go through a little bit of search and retrieval together. So early on in search and retrieval, and I still think the algorithm has some value, which you'll see in my RAG setup video, which is coming up soon. We had kind of this concept of, I guess today you might call it keyword search, but does a little bit different than what it actually is. Of course, it's looking at words, so it's looking at word level, which is what we often do when we think of search and retrieval. And the algorithm that was always like the algorithm to either use or try to beat was BM25, best match 25. And as part of that algorithm, they use a concept which, if you're familiar with my data camp course, is called term frequency inverse document frequency. What does that mean? So let's break it down. How frequent is a word or a set of words in a document? And how rare is that with all the documents? So we're trying basically to say, this is the best document for these words compared with all the other documents. And I give you here an example we have of how you can use it in Python. And again, this is from the RAG notebook, which will be posted soon, walking you through that. But we can call it across our document corpus. So this would be across all of the different texts that we've pulled out of images, that we've pulled out of PDFs, any other text we have, like document text and things on our computer. We've tokenized that. We've created what we call a corpus, so an assembly of those documents that we want to search through. Then we feed it into the algorithm, and then we can send the tokenized query to our search and retrieval algorithm and get back a list of the scores. And those scores are, again, based partially on this concept of term frequency inverse document frequency, which means we take the query terms. So here on the right, we take the query terms, we take the corpus terms, and we try to find a link between them where the less common terms surface potentially the best documents for that query. So why do I even tell you this? This is quite early. This isn't always how things work now. Well, I still think, especially if you tend to type not in question format. So if you type in question format, if you've gotten used to the query, like, does this do that? Or is this that? Or something like that, this might work less well for you. But if you, like me, might still, like of our era, type a topic word literally as your search, then this is actually a really good filter mechanism. And then once you have a filtered set of those documents, you can then do more conversational search. So it's a matter of saying, look, if you have 1 million documents and you want to refine it before you start actually conversing with the search, then this is maybe a really good filtration. And that's how I set up my RAG, my local retrieval, augmented search and retrieval, basically, with my documents. And I'll show you and I'll go through that. But this can be useful, especially depending on if you're building this in a production setting or if you're building it for you, depending on how people search. This can, again, be quite a powerful way to surface things. Okay. And then there's semantic search. So you've probably heard of this, but semantic search is the ability to create links or even networks between different things that are happening in language. Now, here I have an example from Spacey. Spacey is a great open source library for doing things like entity recognition, for doing, all different semantic work with your documents, and is free and open source. And they have a bunch of really good guides. And this is from their guides on kind of how to use the entity part of Spacey. And here we can see we have a sentence. Apple is looking at buying UK startup for $1 billion. And we see that Spacey has found Apple, characterized it as an organization correctly, UK, which is a geopolitical entity, and then 1 billion, which is money, right? So now that we have these entities, we could kind of put them either in a linked graph together based on where they appear in the document, or we could put them as entities that we know exist in this document. Eventually, this can link to or create knowledge graphs, which you might have heard of, which is basically a way that we can link a bunch of entities together, also link documents together and say, hey, all of these documents reference these entities and all of these entities are, linked in this way. And we can start to pull out more nuanced ways of thinking through it, like sentiment. So sentiment meaning, let's say you're working in reviews or something like this. You can say, okay, people have really bad experiences around, let's say, the view at this hotel. So you can start to say this aspect of this entity, people feel this way about, right? Or you can surface things where people have competing sentiments, stuff like that. And all of this, obviously, as I hope you're realizing, means that you have to create a semantic layer, so to speak, that can be searched. That's usually something that you craft yourself. I think that there's tools to do that, but most of them are not open source, or many of them that are open source, like Spacey, require you to really think through how do you want to implement semantic search. But we won't cover that here necessarily. I do think it's really powerful. And I think if you're willing to put the time into it, this can be worthwhile even for your local and home setup. But for me, it personally feels a bit overkill compared to maybe some of the other methods that we'll get into. And I just add here's an example over to the right. This graph is a visual example of PageRank from Wikipedia. I'll link also to the PageRank article, but semantic search tends to be something that people really invest time and money into when search is a core task. And PageRank is a good example of that. And PageRank is, was kind of Google's secret sauce for a long time at winning the search game, so to speak. Okay. And then we have embedded space and vector search. Now, I'll link to a really fun talk about vector databases that I watched when I was in Australia presenting at the YOW conference, which is a great conference if you're in Australia. But I'll link to this talk from Alex on vector databases. But vector search is increasingly becoming a way of looking through your documents. Now, to get vector search working, you have to embed your corpus, you have to embed your query, and then you essentially have to have a good enough corpus and a good enough query that you can use vector distance metrics to determine the best match. And there's a bunch of different vector distance metrics, which means you're probably going to have to experiment with more than one and figure out for the way that you query and for your corpus what is the best that's going to work for you. And again, I just want to put here, this is really useful so long as your queries and your corpus match well and are easily updatable. So you're probably going to have to experiment and figure it out, but can be pretty powerful. So here's just an example that we have from fairly recent history. We have Bad Bunny, we have Super Bowl 2026, and we have Dancing Bush, right? And this also shows you that the recency of your database materials and your query matter too, because, pre-Super Bowl 2026, I don't think these vectors would have been anywhere near each other in any sense. So it matters kind of how much you update, how you query things, but it's definitely worth trying. And in my RAG, I compare the BM25 with this for different types of queries. And that's the beauty of this, is now that you kind of know a bunch of these topics, you could actually combine them in really cool ways. So you could have sentiment and entity. So you could have entity level sentiment. How does this document describe this entity? Is it in a positive way or a negative way? And that can help you surface reviews. So if you wrote a bunch of your own movie reviews, that's a really great way to work on your own movie reviews to see, you know what, I actually don't really like movies with this actor or this director or whatever, right? That could be one cool thing you build for yourself. You could have BM25 to filter and then do vector-based re-ranking. So in search, we can take a list of search results and we can re-rank them, which basically means, okay, we've zoomed in on the 100 best documents according to BM25, and now we're going to redo them with vector search. And that's exactly what I did with my RAG. And again, I'll have a video showing you that. But that can be a powerful way to say, look, let's search and then let's search again within our search, right? As a filter mechanism. You can have a query that can build entities in your knowledge graph, and you can pull those entities out and then create a vector with them, right? So you can do all sorts of cool tricks with this that might work, again, for the way that you search and the way that your corpus works. We can do query summarization. So if you like to type really long things, or if you have some sort of interactive thing where, let's say, you're using an LLM as an intermediary point, and then the LLM is very verbose, so you want to summarize the LLM in a small way and then have a vector search after that. That is also one way to then have kind of the LLM interface lead the query mechanism. And just experiment. So have fun, experiment with what works. Here's a little bit of my RAG notebook, which again, I'll be doing, where you can see I have a prompt, I feed in documents, and then I feed it in the query, and then I ask it to, based on the documents, answer my query. So just a little example from my own personal work that might help you. So I'm excited to hear. Have you been working in search and retrieval? Is there any libraries that you would recommend that I haven't mentioned? I'll put a link to all the libraries I mentioned here in the description. And I'm excited to hear kind of what your experiences are, especially as you get started with creating search and retrieval for your own NAS or local setup. And yeah, what works for you. All right, I'll see you next week.